Welcome to this explainer. Today, we are taking a clean, systems engineering approach to answer a massive question in the AI space. Why, and exactly when, do complex AI agent structures actually make sense? We're going to cut through the noise and figure out why vertical agent teams still have a really powerful future. We'll see how a stronger foundation model upgrades the individual AI worker, but why it takes a brilliantly designed harness to actually improve the entire system.
So let's jump right into this core conditional puzzle. As foundation models get faster and incredibly smart, we are faced with an obvious question. If a single AI agent can already do a task well, can a carefully designed team actually give us a deeper, more reliable result? Why divide the work? Why build out some complex memory system or coordinator when one super capable model might eventually just do the whole thing? It's a completely fair concern. We really need to pin down if structured teams are a permanent architectural necessity or just a temporary band-aid.
Now, let's be honest, some multi-agent systems out there are absolutely destined to vanish. A lot of agent workflows today exist just to compensate for temporary model weaknesses. They chop simple tasks into tiny little steps because a model can't juggle it all. They spin up extra agents just to fix predictable formatting quirks, or they build these massive prompt chains to babysit unreliable behavior. These are totally temporary fixes. Tomorrow's stronger foundation models are just going to absorb these functions, rendering those superficial setups completely useless.
We also have to acknowledge a pretty hard truth. Simply adding more agents does not equal better results. Actually, throwing a bunch of agents at a problem introduces some serious system risks. We're talking about drastically inflating computational costs, duplicating work, and triggering correlated errors. Agents can end up disagreeing without resolving anything, they pass around incomplete info, or they completely fail at coordination. All that does is generate a ton of activity, burn through tokens, and create zero additional value. The system absolutely has to justify its complexity, right? Otherwise, you're literally just paying multiple bots to argue with each other.
And that perfectly sets up our core framework. We're comparing a single capable agent flying solo against a deeply engineered, structured team connected through a central harness. This harness concept is a real game changer, especially when we look at specific vertical domains like medicine, law, or finance. Think about it. These fields don't just need general intelligence, they demand specialized procedures, rigid evidence standards, and strict permissions. To really grasp why a structured team wins in these high-stakes environments, we need to break down how it solves persistent, system-level problems using 7 distinct capabilities.
First up is specialization. This is the fundamental justification for a team. A complex vertical task demands very different flavors of work. One piece is hunting for evidence, another is writing code, another is running compliance checks. Sure, a single agent could try to wear all those hats, but it would have to constantly switch roles, resetting its objective and success criteria every single time. By separating these functions, distinct agents can operate with laser focus. A medical research agent zeroes in purely on clinical data, while a compliance agent worries strictly about regulations. Neither is forced to cram everything into one reasoning process. But here's the catch. Specialization on its own isn't enough, because an agent is pretty terrible at checking its own work. If a single agent reviews its own answer, it usually just carries over the exact same assumptions that caused the original mistake. An independent verifying agent, on the other hand, creates this incredible productive tension. It shouldn't just be asking, hey, does this look right? No, it needs a completely different objective. While a solving agent asks, how can I fix this? The verifying agent is actively hunting for contradictory evidence, asking, under what conditions will this solution completely break?
Which leads us to another massive hurdle, context delusion. Even with today's massive context windows, throwing too much information into one bucket just dilutes attention. If you cram it all in, recent observations can totally eclipse older, way more important evidence, and tiny local details start crowding out the big picture constraints. An agent team solves this through context separation. They divide the context by function. One agent holds on to the global objective, another gets into the weeds on a technical subproblem, and a third guards the evidence record. It's not a workaround for small memory, it's a highly effective way to control where the AI focuses its attention.
Beyond just managing focus, structured teams unlock pure speed through parallel investigation. A lot of work just doesn't need to happen one step at a time. Multiple agents can test competing hypotheses, dig through completely different sources, or poke at different failure modes, all at the exact same moment. This parallelism speeds up a workflow like crazy. But looping back to our warning about costs, the harness has to fiercely control this. Running a bunch of agents is only valuable when the work is genuinely differentiated. If it's not, the system is just paying 5 times for the exact same output. Now, what about workflows that stretch across days, weeks, or even months? For that, the system absolutely needs persistent memory. Real-world vertical work is rarely just a quick one-and-done chat. A legal dispute might drag on for months, and a scientific study could involve hundreds of distinct experiments. The system needs an institutional memory structure that lives outside the model's immediate short-term context. The harness acts as that memory bank. It preserves decisions, failed attempts, exceptions, and unresolved questions, determining exactly what remains authoritative over the long haul.
And once these agents start interacting with the real world, tool governance becomes absolutely critical. Vertical agents might be modifying software, drafting binding legal documents, or touching enterprise financial databases. Not all of those tools carry the same risk. Some actions are easily undone, others have serious, permanent consequences. This requires a major shift from basic prompt engineering to what we'd call authority engineering. As models get more powerful, a structured harness dictates exactly who can execute an action, under what specific conditions, and when a human being absolutely must give approval before anything moves forward. Finally, all of these capabilities culminate in domain integration. Look, a generically smart model might understand a professional field at a broad conceptual level, but it won't magically know your company's specific audit trails, liability boundaries, or internal standards. A truly useful vertical system has to connect that general intelligence to real-world institutional procedures. It has to produce work in accepted formats and slot seamlessly into existing approval chains. This kind of deep institutional integration creates lasting value, and for sure, it's something you just can't get by pulling a stronger general model right off the shelf. Okay, let's zoom out a bit and view this whole setup through what we call the energetic paradigm. Every single time an agent acts, it's consuming limited resources: compute, time, context, memory, tool access, and verification capacity. The harness is fundamentally a resource allocation and control structure. It decides exactly where these limited resources need to go. It makes the tough calls on which tasks actually deserve parallel exploration, which uncertainties need to be escalated to a human, and when the act of coordination adds enough value to justify its pretty steep cost. And that brings us to the ultimate design rule for these systems, the principle of minimum sufficient structure. The absolute best harness is not the one bragging about having the most agents. It's the one that uses exactly what's needed to solve the problem and literally nothing more. Use one agent when one agent is enough. Bring in multiple agents only when specialization, verification, parallelism, memory, or governance create measurable, undeniable value. Actually, a mature, well-engineered architecture will start removing unnecessary agents as foundation models improve. It proves the system is driven by actual function, not just the latest AI fashion. Ultimately, there is a massive difference between replacing a harness and upgrading it. A shallow harness, the kind that just wraps a weak model in extra prompts and fancy industry jargon, is inevitably going to be replaced by stronger model intelligence. But a deep harness, it actually absorbs that new intelligence. When the underlying model gets a whole lot smarter, a deep harness broadens responsibilities, cuts down on handoffs, redesigns its verification around those new capabilities, and converts that raw, upgraded intelligence into dramatically better, specialized system-level performance. As we wrap up this explainer, I want to leave you with a final, provocative thought to chew on whenever you're building or evaluating an AI architecture. The decisive question isn't just whether a single agent can perform a task. The real question is this: can your carefully structured team produce a deeper, safer, more verifiable, and more institutionally useful result than one agent could ever produce on its own? Because if the answer is yes, then vertical agent teams and sophisticated harnesses aren't just a passing trend. They have a very long, very powerful future ahead of them. Thanks for diving in with me, and keep asking the right questions about the systems you're building.